Good morning, Veritas. Happy Monday. This is the lesson from Monday, April 13th, 2020. Hope everybody had a great weekend. Let's get right into it. These are the three problems we're going to work on today. I hope you tried them independently first, and then this is your chance to go back and see, did you get them right? If you didn't get them right, where did you make your mistake? And try to learn on your own while you watch how I solved these problems. All right, so here we go. This week should be a little easier because these problems, I know it says Friday, that's the day you were given them. Today is actually Monday the 13th, April 13th, 2020. So the assignment that you'll find this on is Monday, April 13th, okay? So here's the problem. Number one says Charlie ran 3 times farther than Mr. Spracklin yesterday. Mr. Spracklin ran 2 1/4 miles. So part A says how many miles did Charlie run? And part B says how many more miles did Charlie run than Mr. Spracklin? Okay, so it's about miles. It tells you how much I ran. It tells you how much further he ran. And let's try to figure out how to solve this problem. So I'll start again. Charlie ran 3 times farther than Mr. Spracklin. So 3 times further than me. Mr. Spracklin ran 2 1/4 miles. So if he ran 3 times further, then we have to do 2 1/4 miles times 3, and that'll tell us how many miles Charlie ran. Okay? So we're doing 3 times 2 1/4. So we could do that as 2 1/4 plus 2 1/4 plus 2 1/4. Multiplication is repeated addition. So if we're doing 3 times 2 1/4, we could add 2 1/4 3 times. So that's one strategy we could use to solve this problem. They're all fourths, so we can just add these together. 1/4 plus 1/4 plus 1/4. You add the numerators. 1 plus 1 plus 1 is 3. And fourths are still fourths. There's still 4 pieces in each whole. So the denominator, once they are the same, you can just keep the denominator the same, and you add the numerators. 1 plus 1 plus 1 is 3/4. Now we're going to add the whole numbers. 2 plus 2 plus 2 is 6. So the answer to this problem, if Mr. Spracklin ran 2 1/4 miles and Charlie ran 3 times that far, 3 times 2 1/4 is 6 3/4. So the answer to part A, how many miles did Charlie run? He ran 6 3/4 miles. Okay? Another way that we could have done that using multiplication. The tricky part is you have to multiply 3 times 2, and then you have to multiply 3 times 1/4. So you have to do, you can't just like 3 times 2 1/4. You have to actually break this into 2 plus 1/4. So you're going to do 3 times 2 is 6, plus 3 times 1/4 is 3/4. All right, if you did 3 times 1/4, you can write 3 as a whole number with the 1 in the denominator because the denominator tells you the total number of pieces in each whole. So if there's 3 wholes, each piece really only has 1. Each whole only has 1 piece. So when we have a whole number like this, 3, we can write it as a fraction with 3 over 1. Then we just multiply the numerators. 1 times 3 is 3, and multiply the denominators. 1 times 4 is 4. Okay, so 3 times 2 is 6. And then you need to remember to multiply 3 times the 1/4, which is 3/4. And 6 plus 3/4 is the same answer we got when we did repeated addition. It's 6 3/4. Okay, so that's the answer to the first one. Now part B says how many more miles did Charlie run than Mr. Spracklin? So I'm going to give myself some space. How many more miles did Charlie run than Mr. Spracklin? So Charlie ran 6 3/4 miles. To find out how many more he ran than me, we're going to have to subtract his number of miles minus my number of miles. So 6 3/4 miles is how many he ran. I ran 2 1/4. So if you do 6 3/4 minus 2 1/4, and then just make sure you got the numbers right, 6 3/4 minus how much I ran, which was 2 1/4. To subtract them, we will find out how much more he ran than I ran. So we can start with the fractions. 3/4 minus 1/4. Since the denominators are fourths, we can just keep the denominator the same. And we do 3 minus 1 is 2/4. And now we can do 6 minus 2. We're going to subtract the whole number. 6 minus 2 is 4. So we get an answer of 4 2/4, and we can simplify that. It's still 4 miles, right? Still 4 whole miles. But we can take 2/4, and we can write 2/4 into the simplest form. So if we have fourths, there's 4 equal parts in this whole. 2 of those fourths would be 2 out of 4 total pieces, right? But if we were to put those pieces together and make this just one big piece, and if we put these two together and make a second big piece, now instead of 4 smaller pieces, we have 2 larger pieces. There's one here with the 2 together, and there's 2 here with these 2 together, right? This whole thing. So now the same amount of that was 1 out of 2. So 1 out of 2 equal groups that are bigger is the same as 2 out of 4. So we can write 2/4 as 1/2. If we divide them both by 2, 2 divided by 2 is 1. And 4 divided by 2, we're dividing the numerator and the denominator by the same number. Because if we do 2/4 divided by 2/2, we're really dividing it by 1, because 2/2 is the same thing as 1. And when we divide something by 1, we don't really change it. We don't change the value at all. We just change what the fraction looks like, and we're making it into an equivalent fraction. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So our answer here is 4 1/2. So that's how many more miles Charlie ran than me. If you put 4 2/4, then great job. It doesn't tell you to simplify, but we want to get in the habit of simplifying. 2/4 can be written in simplest form as 1/2. So whenever you have a fraction, you should always check, can I simplify these? Can I divide these both by the same number to make them a little bit simpler in numbers? All right, so those are the answers for number 1. Give yourself some snaps if you did good with those. Those were a little bit trickier. Okay. Now, number 2, straight computation. It just says compute. If you don't know what compute means, look at the problem and see if you can figure out what it means. They're just trying to trick you into, basically, you just have to solve this problem. So I'm going to give myself plenty of space. Here's number 2. It says compute 4 5/6. 4 5/6 plus 3 2/3. Okay, make sure we have them right. 4 5/6 plus 3 2/3. 4 5/6 plus 3 2/3. So I recommend you to write them vertically like this, up and down, right? The 4 above the 3, the fraction above this fraction. But instead of trying to do it sideways like this, I find it easier to do it vertically. That way you have room over here to make equivalent fractions. Okay, so this is the problem we are computing. The trouble is these 2 fractions, you can't just add those together yet because they have different denominators. So we're dealing with different size pieces. So it's going to be it's impossible to add them when you don't have the same size pieces, right? This whole has 6 parts. This whole has only 3 parts. So we need to make those parts the same size, or those pieces the same size, before we can go and add them, all right? So we can always make a smaller number bigger by multiplying. So we could sometimes turn the 6 into 3, but in this case, we can divide that by 2 to get it to 3, but we can't divide 5 by 2. So instead of trying to make the bigger one smaller, we're always going to take the smaller one, because you can always multiply to make it bigger, and you could always make that one bigger too. But you can't always make them smaller. So we're going to turn 3 into a denominator of 6. We're basically saying 2/3 is how many sixths. So we're going to use what we've learned about creating equivalent fractions to help us do that. So 3 times 2 got us to 6. So we're going to multiply times a fraction that's equal to 1. So we need to multiply the numerator and the denominator both by 2. Because then we really multiplied by 2 halves, or 2 over 2. And 2 over 2 is the same thing as 1. If I had a whole here, and if I had 2 out of 2 total pieces, 2 halves, I really have 1 whole. So that's equal to 1. So if I can multiply 2/3 times a fraction that's equal to 1, and this fraction will be equal to 2/3. Those are going to be called equivalent fractions. So 3 times 2 is 6. 2 times 2 is 4. So 2/3 and 4/6 are equivalent. They're exactly the same value. And we know that because we multiplied both of them times the same number to get to this fraction here. Now we have sixths. Now we can add them together. Okay, so our denominator is going to stay the same. Once they're the same, then you keep them the same for your answer. And you're only going to add the numerators. So 5 plus 4 is 9/6. And now we'll add the whole numbers. 4 wholes plus 3 wholes is 7 wholes. But we're not done yet. So this is 7 wholes. I like to put a plus sign here to remind me that we can break this apart. 7 plus however much 9/6 is. Because 9/6, the numerator, 9, is greater than the denominator of 6. So this is actually more than 1. So our answer is actually going to be 8 and some fraction. We got to turn this into a mixed number. We're going to take it from an improper fraction, just like we did on Friday, and make it into a mixed number. So we're going to take 9 divided by 6. So if you have 9 pencils and you're making 6 equal groups, how many can go into each group? 6 goes into 9 only one time. Because if we had 6 groups, let me try to draw this out. If I had 6 groups and I put 1 into each group, there's 6. If I tried to put 2 into each group, I'd have 7, 8, 9, 10, 11, 12. But I don't have 12 to put. I only have 9. So I can only put 1 into each of those 6 groups. So 1 times 6 is 6. We used 6 so far. 9 minus 6 is 3. Meaning that we had 3 left because we put 6 into these groups. So there's 3 left. Because we can't put more into these groups, then they won't be equal groups. They have to be 6 equal groups. So I can't put 7, 8, 9 here because then these groups will have 2 and these ones will have 1. And they won't be equal groups. So that 3 is going to become our numerator of our fraction, and the divisor, the number we divided by, is going to become the denominator. So it's 1 3/6. So 9/6 is the same thing as 1 3/6. So we're going to do 7 plus 1 3/6 to find out our full answer. That's 8. 7 plus 1 is 8, and 3/6 as a fraction. Last step. Our answer is still going to be 8 because we have 8 wholes, and we need to just change the 3/6. So 3/6 we can divide both of those numbers by 3. Then we really are just dividing by 1 because if we divide both of them by 3, we divide it by 3/3, which equals 1. We're just simplifying this so it's in smaller numbers than 3 and 6. So 3 divided by 3 is 1, and 6 divided by 3 is 2. So 3/6 equals 1/2. And our answer is 8 1/2 in simplest form. If you put 8 3/6, then good job. The one step I want you to keep working on, just like with this one, is to simplify that fraction into simplest form. 8 1/2 is the answer. Okay, but it makes sense. 4 plus 3 is 7. Then when you add these together, it's more than 1, so we end up having 8 plus 1/2. Okay? Give yourself some snaps. Those were tricky. We got one more, all right? I'm trying to go quick because the video is getting long now. Number 3. It says to evaluate. If you don't know what that means, look at the problem and try to figure out what you do know. So we have 18 2/9, and we are subtracting 12 1/3. So make sure your place values are lined up, your tens, your ones, and your fractions. We have 18 2/9, and we have 12 1/3, and we are subtracting. You don't know how many times I've seen kids write the wrong fraction or the wrong number, and then they do all this work right, but their answer ends up wrong. So you got to be really careful that you chose the right numbers. Okay, so 18 2/9, 12 1/3. We cannot subtract them yet because the denominators are not the same. So we're going to take the small one and make it bigger and turn it into the bigger one. If it doesn't work that way, we will talk about some problems tomorrow that don't work that way. But since 3 does multiply to get to 9, we're going to just simply turn the 3 into 9. So to do that, we had to do 3 times 3 was 9, so we're going to do the numerator also times 3. Whatever you multiply the denominator by, you're going to multiply the numerator times the same number. That way we really multiply by 3/3, and 3/3 is equivalent to 1. So we're really not changing 1/3, we're just multiplying it by 1, and it's going to look different. So 3 times 3 was 9, and 1 times 3 is 3. So 1/3 and 3/9 are equivalent. They're exactly the same value. So we're going to take it, instead of calling it 1/3, we're just going to rename it for now to 3/9, because that's the same thing. Here's where we come into a little bit of trouble, though. We have 18 and 2/9 minus 12 and 3/9. You can't do 2/9 minus 3/9. If you only have 2 of those 9th size pieces, you can't take 3 of those same size pieces away from it. You only had 2. So here's where the tricky part comes. We're going to borrow from the whole number. We're going to take 1 away from that, which is 17. And we're going to add 1 to the fraction. So how many 9ths is equal to 1? Just like we've been doing here, when the numerator and the denominator are the same, it's equal to 1. So we can add 9/9 here. We subtracted 1 from the whole number, and we added 1 to the fraction. Then we didn't really change anything at all, right? We added 1, we subtracted 1. So it's the same value as it was before. Now we just have to add these fractions. 2/9 plus the 1, which is 9/9, makes 11/9. So we subtracted 1 here, we added 1 here, and then we just had to add it to this fractional part. 2/9 and 9/9 makes 11/9. Now we can subtract 11/9 minus 3/9. 11, 10, 9, 8. So 11 minus 3 is 8. Don't be afraid to count on your fingers. 9ths stay as 9ths. Then we can just subtract 17 minus 12. I'll bet a lot of kids kept this as 18. That's where this becomes tricky. 17 minus 12 is 5. You cannot simplify 8/9 because you can't divide 8 and 9 both by the same number to make them simpler. You can divide this by 2, but you can't divide 9 by 2. You can divide 8 by 4. You can't divide 9 by 4. You can divide 9 by 3, but you can't divide 8 by 3. So since we can't divide them both by the same number, that is our final answer. 5 and 8/9 is our answer to this problem. So those are all the answers. Give yourself some snaps. Nice job. I know I went a little quickly at the end there. Just be careful with borrowing and check before you go to subtract that whether you're able to subtract or not. And if you can't subtract, you're just going to borrow it from the whole number and add 1 to the fraction. That way you didn't really change anything. You took 1 from here and added 1 to here. And now it's the same value. And then you just do your subtraction, check if you can simplify, and that's the final answer. Okay, guys, good luck. We'll have a new assignment tomorrow. Tomorrow's assignment, it says Monday, but this is really going to be Tuesday's assignment about Johanna biking. Be careful with those, and then we get into some other order of operations type stuff here, and we will take it from there. All right, everybody, have a great day. Good luck.